Hello, welcome to 6-3 Solving Systems by Elimination. Now, this is a really cool method of solving systems, and we're just going to start out with the basics today, and then in the next video we will make it a little more complicated. So in order to solve systems of equations by elimination, the first thing we have to do is write the system so that the like terms are aligned. And what that means is write it so that the x's are lined up with the x's and the y's are lined up with the y's, and then the constants are also lined up. And once we do that, we can eliminate one of the variables, and we'll talk about how to do that here in a few minutes. And then once we've eliminated one of the variables, we can solve for the other one. And then once we know one of them, we can plug that into one of our equations to get the second variable, and then we will have an ordered pair x and y as our solution. So we're going to start out solving this system, and as you can see, it's already written where the x's are lined up, the y's are lined up, and then my constants are lined up. So what I'm going to do is I'm actually going to take these two equations and I'm going to add them together. Okay, it sounds kind of weird at first, but it works out pretty nicely. So here I have 3x plus 1x, which is 4x. Now notice here I have negative 4y, positive 4y. So when I add those together, I'm going to get 0y. Or, essentially, my y cancels out. And then I have 10 plus negative 2, which is 8. So I really just have 4x equals 8, and then I can divide by 4 and figure out that x is 2. And then once I know what x is, I can plug it back into one of the original equations. It doesn't matter at all which one I use. So then I'd have 2 plus 4y equals negative 2. And then all I have to do is solve for y. So I'm going to subtract 2. So I'd have 4y equals negative 4. And then I divide by 4. So y equals negative 1. So then I'd have 2, negative 1 as my solution. And just like all the others, we can check this pretty easily. So 3 times 2 minus 4 times negative 1 is supposed to equal 10. So that's going to be 6 plus 4 because it's minus a negative 4. So that works. And then we'll have 2 plus 4 times negative 1 equals negative 2. So that's 2 minus 4 equals negative 2, and that works. So this is in fact our solution to the system. So that's how we solve using elimination. Now let's look at another one. So again, I want to make sure that my y's are lined up, my x's are lined up, and my constants are lined up, and that happens here. So I'm going to take and I'm going to add these together. So 1y plus 2y is 3y. 3x plus negative 3x is 0x. So my x's are going to cancel. And then 14 and negative 2 makes 12. So here I can divide by 3. And I figure out that y is 4. And then once again, I can plug that back into either one of my original equations. So I plug it back into the first one. I'll have 4 plus 3x equals negative 2. So I subtract 4, subtract 4. So I get 3x equals negative 6. So then I divide by 3. And I figure out that x is negative 2. So I have the ordered pair negative 2, 4. And then once again I want to check that just to make sure that it works. So I'd have 4 plus 3 times negative 2 equals negative 2. So that's 4 plus negative 6 equals negative 2. So that works. And I have 2 times 4 minus 3 times negative 2 equals 14. So that's 8 minus negative 6, so 8 plus 6 equals 14, and that works. So my solution is negative 2, 4. So that's elimination by adding the equations together. Now we can also do elimination using subtraction. Now I don't like this quite as much, but I wanted to show it to you just so you knew that it was possible. What happens here, okay, so once again our variables are lined up. Now notice though, if I add, nothing's going to cancel out. I'd get 4x and negative 4y and 8, so nothing's going to cancel out. However, if I subtract, you can see that 2x minus 2x is 0x, so I'm going to get my x's to cancel out by subtracting. Now it does make things a little more complicated though, because you'd have 1y minus negative 5y. Well, minus a negative is really a plus, so that's actually 6y. So it requires a little more thought here. And then again, I have negative 5 minus 13, which is going to be negative 18. So then I divide by 6, and I figure out that y is negative 3. So then once again, I plug it back into one of my original equations. I'd have 2x plus negative 3 equals negative 5. And I know it's confusing sometimes to write 2 signs, so this is really just like 2x minus 3. So then I'm going to add 3. So I get 2x equals negative 2. Divide by 2. So x is negative 1. So I have the ordered pair negative 1, negative 3. And then once again, I would check that. I'm not going to check it here just to save a little bit of time, but I would check that to make sure that it actually works, and I'm pretty sure that it does. If I check it real quick in my head, 2 plus, yep, that should work. Okay, let's look at one more example here. So again, adding it isn't going to do anything for me, so I can also subtract it. So 3 minus negative 2 is like 3 plus 2, so that's 5x. 3 minus 3 is 0, so my y's are going to cancel. And then 15 minus negative 5, so that's 15 plus 5, so that's 20. So then I divide by 5. Figure out that x is 4. Once again, plug it back into one of my original equations. So 3 times 4 plus 3y equals 15. So that's 12 plus 3y equals 15. Subtract 12. 3y equals 3. Divide by 3. Y is 1. So I come up with the ordered pair 4, 1, and then again I'd want to check it to make sure that it works, and I'm pretty sure that it does. So there's my answer. So there's kind of the basic method of elimination. You can use either addition or subtraction. As I said before, I prefer using addition. I think it's a little bit easier, and I'll show you a way to get around having to use subtraction later on. But we can also use subtraction. If it makes sense to you, it works out pretty well. It's just you gotta do a little extra thinking about when you're subtracting negatives and stuff like that. So as I said, in the next video, we'll get into elimination a little bit deeper and talk about what happens if we don't have the same coefficients. Like you notice here we have 2 3s, and that's happened on every problem I've shown you so far. So we'll talk about that in the next video, and I'll see you guys tomorrow.